Hi, welcome to my video on more problems using the area of a triangle. So let's do some more problems related to the area of a triangle, which is half AB sine theta. So triangle PQR has an area of 90 inches squared, and angle P is 40, small r is 20 inches. Find the value of Q to the nearest tenth. Well, if you draw, what I do is I draw the triangle and keep it. So if I name this triangle as P, Q, R, so what happens, because that's angle R, this is a small r, because this is Q, across from it is small q, and because this is angle P, this is a small p. This is the big P. Big P is an angle, small p is the side opposite. So we have the area is 90. We have angle P is 40 degrees. We have small r, which is this one, which is 20. So we're asked to get Q. So the formula for the area of a triangle is AB sine theta, because it has two sides. I have 20, I need Q, I have the area, and I have the angle. So the area is 90, half of 20, B is small q, and I have the sine of 40. So 90, half of 20 is 10, so it's 10 sine 40. So let's work out, turn on the calculator. We're going to work out half of 20 is 10, so it's 10 sine 40 degrees. 6.427, so you can say 6.4 to the nearest tenth, 6.4 Q. Move the calculator away, so I get 6.4 divided. So when we divide that with the calculator, 90 divided by 6.4. Let's see, let's put it back in there. Clear it. 90 division 6.4, and we have to the nearest tenth 14. Okay, we have another one here. Again, pause the video and work these out. Find the area of the shaded region to the nearest tenth of square meters. It's meters, 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 meters. Notice we have two triangles. We have a big triangle. We have this triangle. We want to shade it. This is the quadrilateral here. So we have two triangles. What we're going to do is find the area of the large triangle, and we're going to get the area of the smaller triangle, and then we're going to subtract them, and we'll get the area of the shaded. So the large triangle is this one, so that's a half AB sine theta, so it's a half of 12 and 8. That's a 50 degree angle. That's not 150. That's just a 50 degree angle. Oh, forgot to put the sine in. Sine of 150. So that, got to multiply all that out. So that's here we go. That's a 6. That's a half of 12 is a 6, so I got 48 sine 50. So 48 sine 50 degrees, and I get, again, it's to the nearest tenth, so it's 36.8 square meters. Move the calculator. I'm going to do the small triangle now. I have a half AB sine theta. So it's a half of 5 and 4. Sine of 130. So take a half of 4 is 2, so it's 10 sine 130. So put that back. So I get 10 sine 130. And I have, again, to the nearest tenth, 7.7. So move the calculator. So the area of the shaded is the large one, which is 36.6, subtract 7.7, and that's square meters now. So when you subtract that with a calculator, you get 29.1 square meters. So it's the area of the two triangles being subtracted. The large one subtract the small one, gives you the shaded one. Okay, we have another one to do here. Again, I try to arrange the problems to be a little bit different each time. The area of this triangle is 20.6, and find y to the nearest tenth of a foot. So y is right here, and I have 2x and 3x and 4x. I have this side, and to get the area of a triangle, have a b sine theta. I have the area, which is 20.6. I have one side as 11. I have the other side, which is y, which is I'm trying to find, but I don't have any angle. So y, oh yes, now I remember. I have a triangle, so 4x plus 3x, add on 2x, adds up to 180 degrees in a triangle. The interior angle of the triangle add up to 180 degrees. 4 plus 3 plus 2 is 9x is equal to 180. Divide by 9, so x is 20 degrees. Now, we need, in order to get the area of the triangle, we have two sides, and this is the included angle. So that means 2x is equal to 2 times 20, so that's 40. So this angle right here is 40 degrees. So it's 40 degrees I have to put in here, because this is the angle between these two sides. Yes, this 2 times 20 is 60, 4 times 20 is 80. These are the other angles, but this is the angle I need between these two sides. So, and we have a half, so I'm going to put this in a calculator and clear it. So I have 0.5 times 11 times sine 40. And that gives me 3.535. So if I say it's 3.5 y, divide by 3.5 on each side, cancels. So 20.6 divided by 3.5 is 20.6 divided by 3.5, and I want it to the nearest tenth, so it's 5.885, so it's the nearest tenth is 5.9. And it's the length of a side, so it's feet. Okay. Number 4, again, if you remember, if you want, you can pause the video and work it out. I want to work this one out. So we have this side is 6. These are marked equal, so this is 6. And we have two sides equal. We also have two sides are equal, then two angles are equal. So the sides, if two sides are equal, the angles opposite those. So that means that this angle right here is 30, along with this one. So we have 180 minus these two is 60. So that means that this angle right here is 120 degrees. So that means the area is a half of AB sine of the included angle. So that's a half of 6 times 6 is sine of 120. But I want the exact area. If I type this in a calculator, you won't get the exact area. You get a decimal. So I want the exact. So let's explain how I get 120. Remember, 120 degrees is this rotation. Far as right here, that's 120. This is the terminal arm, perpendicular. So that's 120. This arc here is 60. That means the central angle is 60. So we got a 1, 60. This is a 30. So opposite to 60 is root 3 over 2. Opposite to 30 is a half, but it's negative. And the sign is the y, so it's a root 3 over 2. So 2 into 6 goes 3. 2 into 6 goes 3. So we got a 9 root 3. And again, that's centimeters, so the area is in square centimeters. Using the area. And while I'm at it, I could also, I'll explain it another way. Watch this. If we got a 30 and a 36 and a 6 with 120, remember, because these two sides are equal, I can drop a perpendicular down here. And perpendicular forms two congruent triangles. So that's a 90 and a 30. This splits these angles. So this is a 60 and a 60. And go back to the diagram of a 60 and a 30. This is n, this is 2n, and this is n root 3. So if this is a 6, that means the triangle here is drawn the same as this one. So that means 2n is equal to 6. N is equal to 3. So this is a 3. Oh, n is right here. This is a 3, sorry. N is right here. So that's a 3. This is n root 3. So this side is 3 root 3. These triangles are congruent. So this is a 3 root 3. And that means the area of a triangle is a half the base times the height. And the base is this distance here. So that's 3 root 3 and add 3 roots. So that's 6 root 3. And the height is 3. So half of 6 is 3. So 3 times 3 is 9 root 3. And again, the centimeters. So I got the area using the half, the two sides, and included angle, or I split it and worked at the special triangle and got the area two ways. Okay, another one to do. Find the exact area of an equilateral triangle if the perimeter is 24 root 2. So we got an equilateral triangle has 3 sides equal. So there's 3 sides equal. So if I got an equilateral triangle with 3 sides equal, so we take the perimeter is equal to 3s. So the perimeter is 24 root 2, 3s, divided by 3. So s is 8 root 2. So this is 8 root 2. This is 8 root 2. This is 8 root 2. But we know that an equilateral triangle has all angles equal. So all the angles are 60, because 180 degrees in a triangle divided by 3 gives me 60-degree angle. So that means the area of this triangle is AB sine of the included angle, because we have a half of 8 root 2, 8 root 2 sine of 60, and that's a half 8 root 2, 8 root 2, and the sine of 60, triangle, here's a 60 rotation from here to here, so that drop a perpendicular, so this angle in here is a 60, that's a 1, and that's a 30, so this is a root 3 over 2, that's a half, so the sine of 60 is, sine is the opposite over the hypotenuse, or the y, so that's root 3 over 2. And now we got fractions, so we'll cancel. So half of 2 and 8 goes 4. 2 and 8 goes 4. So we got to be careful now. We got a root 3 is there. So this is 16. 4 times 4 is 60. Root 2 times root 2 is 2. So that gives us 32 root 3. And we want the area is in inches. So the area is inches squared. The exact area. And I did it with 2 sides and an included angle, but I want the exact values, which means I didn't want to use the calculator to get decimals. And the last one to do, parallelogram has sides of 6 and 10. Consecutive angles have measures of x plus 40 and 3x plus 20. Find its area to the nearest tenth of a square meter. So let's draw a parallelogram. Parallelogram is like this. It has opposite sides parallel. So the sides are 6 and 10. Now it makes no difference if you put 6 and 10 here, because the sides are 6 and 10. So the opposite sides are equal and adjacent sides are, so that's 6, 10. These are 10s and these are 6s. Consecutive angles. Well, if you have a parallelogram, the consecutive angles add up to 180 degrees. So this angle plus this one adds up to 180. Or this one and this one ends up to be 180. Reason is opposite sides are parallel to each other. And because the opposite sides are parallel, the interior angles, if you treat this as a transversal, this angle plus this one adds up to 180 at the inside of the parallel lines. Or the opposite, or the adjacent sides, opposite sides of a parallelogram are equal. Sorry, opposite sides are equal. Yes, opposite angles are also equal. That means the consecutive angles are supplementary. We did that in quadrilateral proofs. So we add up the right side. Done. We add up the left side, which gives us 4x plus 60. So 4x is 180 minus 60. 4x is 120. Divide by 4. X is 30. So that means that x plus 20 is 30. X plus 40 is 30 plus 40. It's 70. So if you want, you can make that angle 70. And they're consecutive, so this angle must be 110 because they're add up 180. But let's just check. Let's check 3x plus 20. X is 30. 90 plus 20 is 110, right? Now, we want to get the area. So it makes no difference if we use this angle or this one. This is the angle between these two sides, and this is the angle between these two sides. So the area of the... Now, what we're doing now, when we do that, we're getting the area, but we're getting the area of a parallelogram. So what we're going to do is split it like this. So now we're getting the area of a triangle, which is AB sine theta. These two triangles are congruent, so we're going to find out what one triangle is. So it's a 6, 10 sine of 110. So let me work that out on a calculator here, clear it. So that's 3, a half of 6 is 3, so it's 30 sine 110. So 30 sine 110. We get it to the nearest tenth, right? Okay, nearest tenth. Just looking, make sure. We got a 28.2, and that's for one triangle, and that's in, just to make sure, meters, right? Okay, square meters. But there's two triangles, so there's two triangles, so it's 2 times 28.2, so that's 56.4 square meters. That's the answer. So we did one triangle, then double it. But somebody said, well, why did you use the 70? Well, let me explain a couple of ways. Watch. Do a reliable circle again. And we have a 70. Let's say that angle right there is a 70. Oops. That's a 70. And we rotate. We go to, notice that sine is positive, so this reference angle is 70 here also. So that's a 70, this is a 70. So this rotation here is 110. So in the first quadrant we got a 70, second quadrant we got 110. Both of them have the same reference angle, both of them are positive. So if you did the 110 under 70, you get the same answers. Besides that, watch, if I did the sine of 70, I get 93.96. And if I do the sine of 110, I get 93.96. So either angle would do here. Somebody might ask, well, why did you do 110 and not the 70? Both of them will give you the same answer because they're the same reference angles in different quadrants, and they're both positive. So 70 and 110 gives you the same value. So that's extra problems working with getting the area of a triangle with two sides and an included angle. And again, if you like my video, click the like button. If you're not a subscriber, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Bye-bye.